So now I'm going to bring back David Reay from CPL Activated Carbons. Hi, David.
Hi.
I've lost your introduction. Very briefly, just in summary, David has a degree in chemistry and member of the Chartered Institute of Marketing. He's a very career, including chemicals, automotive, and aerospace, all around the world, including Wigan. And he's been with CPL for 13 years. In carbon for 13 years, having joined CPL in 2016, where he's responsible for all aspects of the company's marketing and promotional activities. So, David, over to you, sir.
Great stuff. Thank you, Ron. Can everyone see my presentation now?
It's up.
Fantastic. Okay. Good afternoon, everyone. Apologies for the gremlins before. Not quite sure what happened there, but I will dive in. Thank you for the opportunity to present today. I want to give you a quick introduction to my company, what we do, our products and services, and then move on to the issue of carbon selection, which is of interest, particularly for odor control applications, and then finish with a couple of case studies. So CPL Activated Carbons, we've been around since 1990. We were 30 years old last month. We started life as Carbon Link Limited. Some people still refer to us by that name. We've been reactivating spent carbons and recycling them since 2013. But the big expansion for us was 2018. We more than trebled our ability to reactivate what we call amber list spent carbon. So that's from industrial processes like odor control, biogas, that type of thing. And we also started reactivating green spent carbon. So that's typically from drinking water applications. And it was also the year we started manufacturing our own mobile filters, and I'll talk a bit more about those later. We're a very technical team, and carbon is used in many hundreds of applications, but we're market leaders in a number of key applications, some of them which are mentioned there, particularly here in the UK market. Some of our customers are shown at the top. We either supply directly or indirectly to a number of the big wastewater utility companies, as well as a number of the waste type handling companies. And we think we're doing a good job. Our sales have more than trebled in 5 years. And I doubt that there are many companies that can claim that, certainly in the current climate. So moving on to our capabilities, we have UK manufacturing plus R&D here in the UK. Many of our impregnated grades, so these are typically products used for odor control and biogas, they're made here in the UK as well. We have 2 separate reactivation capabilities for spent carbon. We have 8,000 tonnes of amber waste, again, so this is industrial. And then we have 2,500 tonnes for drinking water type applications in these completely separate buildings up at our site at Immingham on the East Coast, where we also have QA and R&D to back up that production capability. We have multiple warehouses and waste transfer stations, and we have the latest environmental and quality accreditations. Activated carbon, as you may know, is used in many hundreds of different applications, some of which are shown down the left-hand side there. We're involved in all of those. What do we do? Well, in addition to supplying the carbon itself, we also supply on-site services. So we assist with the installation and removal of activated carbon. We can also supply mobile carbon filters, and we can supply all the engineering capability that goes with that. So if you need pipe work, valves, flanges, that type of thing, we can do all of that in-house. Wherever possible, we recycle spent activated carbon. We call the process our Regenesis service, and we also assist customers with waste handling. So an important and growing part of our business is the supply of mobile carbon filter vessels. We call them our clean flow range. We design and manufacture these in-house at our subsidiary, CPL Icon. They're based in Chesterfield. We have a large and growing fleet of filters of various sizes and capabilities, from 2 cubic meters up to the very large 30 cubic meter vessels you can see at the top there. Those stand 7 meters tall, so they're quite sizable units. We have units for gas phase and liquid phase applications. And of particular interest to the odor management type sector is we have a number of high flow variations available that can take a very high flow of air or gas, perhaps with a lower concentration of contaminants compared to, say, a biogas type application. Many benefits of using mobile filters. Obviously, they are fully portable. They offer you a modular concept. You can install one or multiple filters. You can have them in parallel or in series, have a lead and lag arrangement. So you can set up the arrangement to suit your particular application, and every application is different. And of course, there's no on-site carbon handling. We supply a carbon filter full of fresh carbon, and when it's spent, we'll simply replace the whole filter and take that away for recycling. So as I mentioned, we have a number of high flow units. We call these our Voxorbers of various sizes. Our current flagship is shown on the right-hand side. That's a 30-foot container. We call it the HF24. It contains 24 cubic meters of carbon, and it can cope with flow rates of up to 45,000 cubes an hour. So that's a big flow rate for a mobile carbon filter, typically used for waste transfer stations and very large volumes of air. We heard some flow rates mentioned by other presenters. And just for information, we are currently developing a vertical version of that filter where you don't have the floor space, the footprint available for a 30-foot unit sitting horizontally. We're going to be providing a vertical unit as well in the near future. So that's a quick, very, very brief introduction to what we do. Hopefully most of you are familiar with our business. But I want to move on to the issue of carbon selection. So the choice of carbon really depends on which compound or molecule you want to remove from your stream. Things to consider include the molecular weight and the boiling point of the compounds and any particular functional groups on the molecule. Also, the process conditions are important. What is your inlet concentration, and what is your treatment objective? How low do you need the contaminant to go to satisfy the requirements of your permit, of your process? Other factors are important too, like presence of moisture, and particularly oxygen, and I'll talk about that when we talk about impregnant types. Obviously, economic considerations are important too. Price versus bed life is a common discussion we'll have with customers. Do you want to pay for a more expensive, higher spec carbon and enjoy a longer bed life and fewer change-outs? And that's particularly important if the accessibility of the carbon filters is difficult, or simply you want to reduce downtime of your process. I mentioned mobile filters, but we can also supply fixed filter units. There's a drawing there at the bottom of one of our our fixed odor control vessels. That's a 12 cubic meter vessel, and that'll typically be used at a wastewater treatment plant. So, as most of you know, activated carbon is a high purity form of carbon with a very high surface area, typically made from coal, coconut shell, or wood. Although I have to say other biomass types are always being investigated, and we have an active R&D program looking at that. For gas phase applications, most of you will be familiar with extruded pellets, so typically 4mm extruded pellets, but increasingly most carbon companies will also offer a large granular variant. Offers no negative performance characteristics, but it often is a more economic version than a manufactured pellet. The carbon can be a virgin carbon, i.e. brand new, or it can be regenerated after our reactivation process, and it can be a standard carbon or an impregnated grade, and I'll talk a bit about impregnation on the next slide. As a rule of thumb there, coconut carbons tend to be used for low molecular weight impurities, coal-based for higher molecular weight impurities. And in terms of gas phase, you don't see wood-based carbon being used very much. They're very soft, so they tend to be used as a powder form for pharmaceutical, chemical, food and beverage type purification applications, so not relevant to this audience. So standard carbons are very good at removing your most organic impurities. So that's your standard VOCs, your siloxanes in a biogas stream, that type of thing. And the process is referred to as adsorption. The molecules are attracted to the pore structure on the carbon surface. However, for some contaminants, you need to modify the carbon surface to promote an efficient removal. So this is typically for inorganic impurities or particularly polar molecules that are poorly absorbed by regular carbons. So typical examples, hydrogen sulfide, ammonia, mercaptans, things like that. And here you're promoting an actual chemical reaction on the surface of the carbon, which we refer to as chemisorption. And this is what is typically used in odor control applications. You have to remember you need a longer contact time with the carbon to achieve an efficient chemisorption process compared to a standard VOC type application. And as a reminder, most of those impregnated carbons are made here in the UK. So the choice of impregnant really depends on the compound to be removed and other process conditions. I've highlighted there oxygen. That's, in our experience, one of the critical issues that affects odor control applications. And there's a lot of information on the next bullet point. I won't go through it all because we don't really have time, but it basically shows you a variety of impregnant types and how they're used in different process conditions with different oxygen levels. The first four are all for sulfur-based contaminants, H2S, for example, and it starts with more than 2% oxygen. So we use a potassium carbonate, and then for lower levels of oxygen, we have copper oxide, potassium iodide, and potassium hydroxide. So, we can offer a standard grade or even a custom grade, but we do need to work with customers to look at their process conditions and find the optimum solution. Other contaminants, ammonia and amines, we generally use a citric acid impreg, so our SA66 product. And for formaldehyde, we have a very specific grade, sodium metabisulfite, which is our SA67. So that's just an indication of our standard grades. We offer combinations of blends of these impregnated products as well as completely bespoke items. Obviously, they give excellent performance, but you sometimes have to consider an increased cost. So I've got a couple of case studies, which hopefully I've got enough time available to go through. Both of them are at wastewater utility plants, wastewater treatment plants. The first one was an odour issue caused by dimethyl disulfide, DMDS. They were using a competitor's carbon that was unable to remove all of the odours. And if you look at the grid at the bottom, 4 contaminants that are listed there, hydrogen sulfide and a couple of mercaptans. The competitor's caustic impreg carbon did a very good job at removing those 3, but it basically didn't touch the DMDS. It went in at 4 ppm and exited the filter at 4 ppm, so had no impact at all. And the reason for that is actually DMDS is actually poorly absorbed by impregnated carbon. It's a bit of a quirk to the rule. So our proposal was to install a second filter, what we call a polishing filter, and use a virgin non-impregnated carbon to remove the DMDS. And we also proposed to switch from a potassium hydroxide impreg to a copper oxide impreg for the main filter. And the results are shown at the bottom. Again, the first 3 contaminants are removed to almost non-detectable levels, but importantly, DMDS was reduced from 4 ppm down to less than 5 ppb, parts per billion. So critically, no more odour complaints from the surroundings. So that was a good result. Second case, another odour issue at a wastewater treatment plant. And here the problem was 0 or very low oxygen conditions. They were suffering, they were having to change out the carbon filters every 2 to 3 weeks with a competitor's product. And it was because the oxygen level was much lower than expected. And that reduces the ability of the carbon to remove these sulfur-based compounds. It basically inhibits the chemisorption process. So we did some trials with 2 carbon types, and we measured the bed life both with and without added oxygen. As you can see there, we used a caustic impreg and a special dual impreg carbon. And without added oxygen, both lasted 6 weeks, which is already more than the competitor's product, which is a good result. But critically, when we bleeded in some oxygen, the life more than trebled to 20 or 21 weeks. So it was pretty clear to both to us and the customer what was required. So yeah, so even without oxygen, both of our grades doubled the bed life, but with 1% oxygen via a purge valve, the performance increased dramatically. So that's the direction the customer decided to go. We used an oxygen generator, and they actually chose the dual impreg carbon to give them the optimum conditions against a range of contaminants. The bed life was maintained at the expected levels based on the trials, and again, critically, no more odour complaints. That's the bottom line. So just a couple of case studies there. So summary of the case studies then, we will always help customers solve their technical problems, and we have a huge experience in most critical carbon applications, and we have a very wide range of products to solve those problems. We have a technically capable team, and it's backed up by full R&D if lab testing is required. And we have the option to use mobile carbon filters for testing and evaluation, or indeed if an additional filtration step is required, as we often see with odour control and some biogas applications too. So that's all I wanted to say today. Just a quick summary of our company capability. We're very proud we're the only UK carbon company to offer all of these capabilities. UK production of specialised impreg grades, recycling of amber list spent carbons. Just I didn't mention that we think there's a CO2 footprint saving of about 90% by using recycled carbon. In-house production of mobile carbon filters, backed up by in-house engineering capability in terms of design, manufacture, and install. Again, all the pipework and flanges, we can do all of that in-house, take that pressure off. We have a nationwide network of site support services, and you can see one of our site service vans there. That's actually the landfill site, landfill gas site, where they have 3 of our large 30 cube mobile filters. And again, full backup of R&D and QA to support the sales and the technical function if required, and the latest accreditations. So that's really all I wanted to say. Just give a whistle-stop tour of our company and our capabilities. We have an exhibitor booth at this event manned by our technical manager, so please come and talk to us in detail if you have particular questions or issues you'd like to discuss, and my email is there as well if you'd like to email me after the event. I hope that's been useful, and thank you for your time.
David, thank you very much. Running a little bit behind, but I did just want to touch on, I mean, my background's mostly sewage works, especially on sort of sludge sides. You tend to have a biofilter with an activated carbon polish in general. One or two sites that I've tended to see tend to get a little bit of water carryover. What do you find the impact of carried over biofilter water tends to be on the lifetime of the carbon? And is there any way to recover it afterwards?
Water is never welcome in a carbon filter, I have to be honest. For certain applications, we promote putting a chiller in the stream to take the water out. You basically got to let the carbon do its job, which is absorbing the impurities from the gas. So yeah, there's no denying it will reduce the life of the filter, but there's some usually fairly simple solutions to remedy that. And in terms of biofilter, people say to me, "Oh, it's a competitive technology." In all the applications we deal with, it's complementary. Same with water treatment, same with odor control. We can't deal with thousands and thousands of ppm of H2S, but activated carbon, correctly specified, does a very good job at taking down that final step, that final polishing step. So yeah, it's specifying, it's working with consultants and specialists to specify the overall situation. But now we're moving into these larger filters, of course, that perhaps moves the goalpost ever so slightly. You can do more with carbon than you perhaps could do with before, which is why I wanted to mention those high flow units.
There's just one question come through from David Castle, which I think may have been answered by in the chat by Matthew Webb, but I'll put it to you anyway. What is the typical weight to weight percentages take up that you can achieve for ammonia?
For ammonia, I just refer to my technical colleague over there. Ammonia take up, Matthew. 10 to 15% is the word I'm getting. Sorry, always pass the buck when it comes to technical questions.
Understood. I know that feeling very well. So on that note, I'm going to say thank you very much. Apologies for the a couple of glitches earlier on, but
my apologies too. Yeah.
Thank you.
Thank you.
Cheers.